All right, this is part 2 of our video for this lesson, and picking up where we left off. We were talking about heating and cooling curves, and I'm ready to do the sample problem. However, let's just recap. We left off talking about this being at the top. This is for a temperature change, this being a phase change, this being a temperature change, this being a phase change, and this being a temperature change. Now, not all heating and cooling curves have all of these 5 regions. I'm just showing you the maximum. Again, remember, if it's a temperature change, you're going to use your equation Q equals mc delta T, and Q is going to be in units of joules. If it is a phase change, Q is going to be N delta H, and Q is probably going to be in units of kilojoules. Then when you are all done, you are going to take all of your Q's and add them up to get your Q total. So Q for each one of these regions, Q total, not Q total. And so your joules and kilojoules cannot be added together. You'll have to make them all into kilojoules. So we'll cross that bridge later on. All right, so let's look at our first example. How much energy would it take to heat up? So right there, our phrase heat up, we know this is going to be a heating curve. I'm going to draw this. So we have time, and we have temp. Oops, sorry. All right, we are starting at ice at -10, and we are going to steam at 102. And again, this is H2O. So it's very important to remember that water has a boiling point of 100 degrees Celsius and a freezing point of 0 degrees Celsius, or a melting point of 0 degrees Celsius, since we're heating it up. So here's our 100, and here's our 0. And so we're starting off at -10, and we're going up to 102.5. Remember, this is not quantitative, so we're not worried about how far above and how far below on this picture. So we are going from -10 to 0. At 0, our energy is going to be used to melt that ice. Then, once it's all melted, we're going to go to 100. Once we're at 100, we're going to boil that water. And then, once it's all boiled and it's all steam, we're going to continue to heat that steam up. So these are our 5 regions. We have 1, 2, 3, 4, 5 regions. So I'm going to call these Q1, Q2, Q3, Q4, and Q5. Again, looking at these, the ones that have a slope involve a temperature change. And for all of those, Q is going to be equal to mc delta T. Why did I pick 1, 3, and 5? Because these are the ones that have a slope, positive slope here. I guess I could change the color. So we have a slope. difference, though, is the fact that in the first one, from -10 to 0, this is ice. In the third region, we're dealing with plain old water, liquid. And in the fifth one, we're dealing with steam. All right, let's look at 2 and 4. 2 and 4, we have plateaus. That means we have a phase change. So that means we're dealing with N delta H. Which delta H we're dealing with is different. At 0, we're going between ice and a liquid. And so that means we're melting. The other word for melting is fusion. So that's delta H of fusion. And in stage 4, we're going between a liquid and a gas, and that's vaporization. So now we have it set up, we're ready to kind of just plug and chug. The only difference is M is mass, which we know what the mass is, but N is moles. So we have to do a little dimensional analysis here. So let's do this off to the side. 50.0 grams, and we know 1 mole of water weighs 18.02 grams. So I'm going to convert that, and once I do, that is 2.77 moles of water. So I'm going to go ahead and plug that in, 2.77 moles. But that's the only one with N. The other ones have M, so I can just use 50.0 grams. So 1, 3, and 5, I can use 50.0 grams. C, for ice, they give it to us in the problem is 2.05 joules per gram degrees Celsius. Delta H of fusion, you have to look back on the prior page, and that is on the last page of your notes under section B. The delta H of fusion for water under section B is 6.02 kilojoules per mole. So again, we're on letter D. If you go back up to letter B, the delta H of fusion for water is 6.02 kilojoules per mole. C for water, this one you should know, 4.184 joules per gram degrees Celsius. Delta H of vaporization, also in section B, right where I got that 6.02 from Q2, it is 40.7 kilojoules per mole for water. The C for steam, right up above in this problem, 1.90 joules per gram degrees Celsius. All right, going back up to Q1, delta T. Well, delta T, here's where some kids get confused. So let me change sections right here. What's delta T for just stage 1? From -10 to 0, the delta T is 10 degrees Celsius. It goes from -10 to 0. That's a change of 10 degrees Celsius. In Q3, what's that delta T? From 0 to 100. That's a delta T of 100 degrees Celsius. And finally, in Q5, what's this? From 100 to 102.5, that's just a temperature change of 2.5. So you have to break down the temperature changes of just each individual slope area. You cannot do the overall temperature change. All right, so let's break all these little sections down and do the math. So in the first one, Q1, I take 50 times 2.05 times 10 with, let's see, oh, it's 10.0, excuse me. And I get 1,030 joules. Q2, N times delta H is 16.7 kilojoules. Q3 is 20,900 joules. Q4 is 113 kilojoules. And Q5, when I multiply those, I get 240 joules. Now, what I have to do at the very end here is add all these together. And the problem is, some of these are in joules and some of these are in kilojoules, and I can't add them all together until they're all in the same unit. So I have to move my decimals over. So that makes this, the first one, 1.03 kilojoules. That makes this one, when I move it over 3, 20.9 kilojoules. And it makes the last one 0.24 kilojoules. When they're all in kilojoules and I add them up, I get a final answer of 152 kilojoules. The last one's pretty easy because it says how much energy would be released at water at 20 degrees Celsius cooled to be frozen at 0. So all we're doing is going from 20 to 0. That's all we're doing. So we only have 2 regions, 1 and 2. 1 is a Q equals MC delta T, and 2 is a Q equals N delta H. First one is 150 times 4.184 times negative 20, because we're going down. The next one, once I convert my 150 grams to moles, I'm running out of time here before I hit my 15 minutes, sorry. I get 8.32 moles. This is negative 6.02 kilojoules per mole, because it's the opposite of fusion. Q1 is negative 12,600 joules, which is negative 12.6 kilojoules. Q2 is negative 50.1 kilojoules. So when I add that together, Q total is negative 62.7 kilojoules. So you have to look. This I knew was only going to be 2 regions because I was already a liquid and I only wanted to freeze it at the freezing point. I wasn't going beyond the freezing point. So you have to just look at where you're at. Look at how many regions you have.